Hi students, greetings from MPower by Dr. NK. Today let's have some fun. You have all been aware of ozone depletion, right? Can you guess which kinetics does ozone depletion follow? Are you not curious? This is just for fun, not for the exam, but it's interesting to see the kinetics of ozone depletion. Again, here we are going to see the data which is given and also relate it to the equation and find out what is the order of the reaction. All right. In order to find out the total order of the reaction or the order of the overall reaction, we need to know whether the reaction is happening in a single step or more. Also, we need to know which one is faster than the other if the reaction is taking place in more than one step. Now, if you take the conversion of ozone or the depletion of ozone or the decomposition of ozone, the overall reaction is given by 2O3 giving rise to 3O2. This depletion happens in two steps. In the first step, the ozone is getting converted to oxygen and gaseous oxygen and nascent oxygen in the gaseous form. And the second step consists of the reaction between ozone and this nascent oxygen to give you molecular oxygen, right? Among these two steps, the second step is the slow step. And if you remember, let me draw your attention to the rate equation and also the rate determining step. If the reaction is taking place in more than one step, the slowest step will be the rate determining step. In this case, it is second step, in which the ozone combines with nascent oxygen to give you molecular oxygen. Now, if we need to find out the order of the reaction, we need to go write the rate equation for the slowest step. So for the slowest step, the rate is given by K dash into concentration of ozone into concentration of nascent oxygen. Call this as equation 1. But for the first step, the rate constant K is given by concentration of molecular oxygen into concentration of nascent oxygen divided by concentration of ozone. Now, we don't know the concentration of nascent oxygen, therefore, we can write concentration of nascent oxygen in terms of the rate constant K of the first step as K into concentration of ozone by concentration of molecular oxygen. Call this as equation 2. Now, all we need to do is substitute the value of concentration of nascent oxygen in equation 1. We are going to get rate as K dash K into concentration of ozone square into concentration of oxygen to the power of -1 because concentration of oxygen is in the denominator. Now, what is the overall order of the reaction? You just have to take the exponents of all the concentrations and add them up. By doing that, we can see that the overall order is 2 minus 1, that is equal to 1. So ozone depletion also follows first order kinetics. That's interesting, isn't it now? For more interesting questions and easier way of solving problems, keep watching this space. Like, comment, share, and subscribe to the channel MPower. And do not forget to download the MPower app. Do it now. See you soon.